This is SBOLDesigner 2.0, a sequence computer-aided design tool for designing genetic constructs using SBOLD 2.0. So on the bottom, you can see we have a row of parts, and if we click on any of these parts, we can drop them onto the canvas. So today we are going to be making the genetic toggle switch that's composed of the TED-R inverter and the LAC-I inverter. But first, we're going to make the TED-R inverter. So this is composed of a promoter, the LAC-I gene, and a terminator. And this LAC-I gene is composed hierarchically of a ribosome binding site and a coding sequence. So as you can see there, if I click on the LAC-I gene and focus in to that gene, I can see that it's actually composed of a ribosome binding site and a coding sequence. And on the right, I can see, if I click on Overview, I can see the top level design. So if we know what parts we want to use, we can actually import them from a registry. So if you click on Preferences, Registries, you can see that there is a default list of registries. So this includes the built-in parts, a working document, that's your current working document, and the Newcastle instance of the SBOL stack. You can also add registries if you wish. So if I now select on the promoter, I can fetch from a registry. So here I can select which registry I want to import from, let's say the SBOL stack. And then I can also say the part type. So for example, DNA, RNA, or protein, I can select the role. So that's all of these parts. And based on the role, I can have a refinement on the role. So if I know, say, I want a constitutive promoter, I can click on the constitutive promoter here. So we know that this is BBA R0040, the TED-R promoter. And then we also know that the terminator is this. So right now we are completely just importing from the SBOL stack. Of course, this does require an internet connection, but if you don't have an internet connection, you can still import from local repositories and the built-in parts. So now we can select the RBS we want and the CDS we want. So this makes design very simple if you know what parts you already want, because you can just select them from registries, and it's all handled within SBOLDesigner. It's all built in. So not only can we fetch parts from these repositories, we can also upload. That's this button right there. So say you're finished with this design, then you can actually upload it and use it in a different design by downloading it again from a repository. And here's the LAC-I coding sequence. And now if we focus back out, we can see that we've completed the TED-R inverter. So now we can save that into our genetic toggle switch file, our SBOL file, and we can work on the other part of the genetic toggle switch. So in the interest of time, I've already made this, the LAC-I inverter. You can see it's also a promoter, a terminator, and then the TED-R gene and the GFP gene. And if you focus in onto these, you can see that they are also made of an RBS and a CDS. So let's say we want to compose these two inverters hierarchically and make the top level genetic toggle switch. Then we can do it like so. So first we have the LAC-I inverter, and then we have the TED-R inverter. So you can also flip the orientation like that. But if you focus in on this right now, you can see that it's actually not hierarchically defined. So now what we can do is click on the flashlight icon again, navigate to the working document registry, and import the LAC-I inverter. So now when we focus in, you can see that the LAC-I inverter that we previously built is now associated with this part. And we can do the same with the TED-R inverter. So you can see there, if I focus in again, you have the top level genetic toggle switch, and then you have the TED-R inverter. That's what this box is defined as. And then the LAC-I gene inside of that is this RBS and this CBS. So now that we've created our top level genetic toggle switch, you can see that the sequences are actually all composed and stitched together for you by the tool because you defined it hierarchically. Oh, I didn't click save. And now we can save the SBOL file back into the same SBOL file. And now we have our design.